Hey, how are you doing? I hope you all are doing great. It's still the coronavirus situation is not so favorable that we can, start in-person lectures. But I believe that compared to the last years, even last semesters, we are more resilient to cope up with these overall situations. And I welcome you to this, second semesters of our online lectures. And this course is multimedia. And perhaps some of you may know me that I'm Professor Yazid Islam here at Sejong University at the Department of Computer Science and Engineering. So this course, multimedia, you perhaps have your own idea that what you are expecting to learn from, but that might not be the case. And perhaps some of the things that you were not familiar, or maybe some of the things you were lightly familiar, but whatever. So in the beginning of this lecture, so this week we'll be confined ourselves to the introduction of this course. So let's get it started. And in the beginning, so as a motivation, so let's see, how is this one? So we can think of the readily that let's say medical applications. In medical applications we can use multimedia. So for examples here, if you look at this side, this is an X-ray. So X-ray is simply a photograph, right? It's a photograph that you pass X-ray through the body, and then other side you keep a plate, photographic X-ray plate, and on the X-ray plates you saw some images, right? So that means this bone and something. So based on some sort of expertise, you can determine that is there any defect or is there any problems or not. Now things have been changed a lot since then. So think about these pictures at the right side. So this is MRI, this magnetic resonance imaging. And in magnetic resonance imaging we use lots of sophisticated algorithms, image acquisition techniques, image processing techniques, and whatnot, right? And even the environment sometimes we create to take a good pictures, and all is, and even in the video forms. So compared to X-ray, this was a plain and simple, but this MRI become much more attractive and useful, complicated, and this is also some sort of multimedia. Now in a bigger perspectives, now see the truly multimedia things is like this one. See that in various kinds of training simulations, for example, you may not get the patients always, for example, the dental treatment or some other complicated disease. So what we can do, we can prepare some augmented reality or virtual reality based video, and using that video, the trained learners, they can actually learn that how to treat those kind of things. So this is a wide scale now multimedia applications. So now another perspectives of multimedia applications, see here, this is this is very much expected and much more useful things in today's hyper-connected society. And so we are communicating with online our doctors, right? The doctor give the prescription based by observing real times, by observing the patients in real time. But definitely we need to supply very cutting edge communication technologies to support these multimedia applications. So this is a glimpse that even in a medical domain, how multimedia can be useful. So now, we didn't explain anything, just straightforward we are talking on that, right? But whatever, let's we move forward. So multimedia, ultimately this is a 3 credit course, and the lectures would be 3 hours weekly. And if it becomes face to face, so perhaps on Monday and Wednesday, and that is 10:30 a.m. to 12, and on Wednesday 10:30 to 12. So this is 3 hour lectures. But when it comes online, so at least for each day, that is for Monday, we have 38 minutes online lecture at least, and for Wednesday we have 38 minutes online lectures, video lectures at least. So that means the total is at least 76. So let's say 80 minutes video lectures we'll have to watch if we like to take the attendance for 1 week, something. So, and definitely the online mode would be the Blackboard, and a few lectures, a couple of lectures that perhaps invited lectures, or maybe I myself would provide via WebEx or Zoom. It's live lectures, okay? And the lectures would be theory, tutorial, some demonstrations, but it's all about through lectures. And attendance, please follow this guideline. I will upload this slide definitely. So it's 5 minutes before and 10 minutes after lecture is starting, so this is counted as attendance. Otherwise, if 10 to 15 minutes after lecture sharing, so the starting, so that would be counted as late, and 15 minutes after generally considered absence. But now this is online lecture, so definitely we must follow this kind of norms. And for others related things, you can see that when we post the lecture, so in that for each lectures there is a particular time period that for which we must watch the lectures. Okay, so that's why I'm saying that for online lectures, time, attendance, and other regulation, see the notifications in Blackboard and online lecture posting. Okay, so please make sure that you really watch that lectures for that prescribed and set time. Otherwise your lectures attendance will not be counted. Now I need to say one thing. Okay, I'll tell you a little later for that one. And because it is online lectures, but to have the better communications among the fellow students, so we'd be creating a Kakao Talk group chat. And the Kakao Talk is basically a messenger app. So in Korea it is very useful. So you can install Kakao Talk in your mobile app and you can take part in the group chats. And I will share the details. That I will give the link and you can click the link, and I'll give you the password. You can enter the password, so you can start the group chatting. So you can treat that things as like a classroom, yeah, so where students can ask something each others. But definitely I will not have time to go through each of that chatting. So if you have questions particularly to me, so definitely you will have to email me. That I will say how to contact me a little later. Okay, so now let's say formally we see that what are the applications that we are trying to see. So applications, or why we need to study multimedia. So as I said, in educations, for examples, we have this complicated human organ, and it is very hard to draw these pictures on the blackboard or whiteboard that in our classroom. So what we can do, we can take these pictures, we can zoom in, zoom out, all we can things, and we can study well, right? We can also use multimedia a lot in advertisement world. So it might be online advertisements, or it might be television advertisement. You perhaps know that what I'm talking about. And multimedia is used heavily on entertainment world. Definitely the entertainment is a big, and everybody you perhaps, or even we can link the multimedia with entertainment when it comes to multimedia world itself in front of us. For example, the music industry, we play various kinds of instruments, and how to deal with those sorts of instruments, how to control that, and we need the multimedia knowledge even for that. And from computer science and perspectives, we have to control those instruments digitally. So how about then now data visualizations. Data visualizations is also, see, it's taking the color concepts, image concepts, and how human perspectives work, how so that things together, it play a role, right? So all of this design issue, as well as the combination issue, color issue, presentation issues, so these things. So in data visualizations, because data is great things, but presenting the data to different kinds of audience, to a diverse audience, is always a challenging task. So that's why data visualization is now becoming a part of the multimedia itself. And definitely other big use of multimedia is computer games. And I don't need to explain that how we use this multimedia. Everybody, we are somehow familiar. In communications, we use, communications mean communications among ourselves, in a team meeting, on online meetings, and collaboration aspect, we use, multimedia stuffs, because we are using, we are communicating with our conversations with other help text and other kind of, audio, video stuff. Now, definitely in some other aspects, let's say the recording memories, right? In a CB, you go and you take the photo and you preserve it. So these also, the applications of the multimedia. Now another very potential use of, and not only potential, very widely used applications of multimedia is let's say this photo enforcement. In photo enforcement mean you set up the speed camera and it's automatically detect the car speed, and if it do the over speeding, so definitely it then goes to the server and automatically record it, and some fine and penalty goes to your home, right? So that's also a big area of multimedia application. Now think about the a little bit different applications. First of all, think about this one. Virtual influencers. See, these virtual influencers, these are the people, but it looks like they're real people, but they are not the real people. They are basically computer generated people, right? For example, in Korea, perhaps you might know that Sua, Rosie, Kim. So they are some very popular character. So they have their own social media sites. They update their status, they post photos, they go and they advertise some products, so they become the product ambassadors, and very much they behave like as if they are real people and the real influencer motivator, right? So this is this virtual influencer, virtual things is becoming a reality actually. So this is a cool application. Another, very useful applications that I give a hint is online lectures. You see that we use, Zooms or those kind of things. We use, online real-time exam. Perhaps you are already familiar with these things that, through WebEx or through Blackboard, we conduct the online exam. So these are cool applications of multimedia, or at least we can say the multimedia are heavily involved. It is not just multimedia stuff. There are so many other things we need to integrate, but multimedia is truly an interactive and interdisciplinary field, that I would say. Interdisciplinary in a sense that you need knowledge and skills from many fields, from creativity to your computer science knowledge. Okay, now we are talking about multimedia, but what is multimedia we will be explaining formally in the next part, but here I like to give some sort of idea on that. For examples, you have text data, you have audio data, you have image data, you have video data, you have animation data. So those are basically, we say, multimedia data. Now you already know that text data, for example, so let's say a character A, B, C, D, or let's say we have the computer keyboard, and in the computer keyboard when we press A or when we press 1, actually this converted to all the binary data, right, ultimately. And this A is basically is equivalent to decimal 65, and this is actually in binary. If you represent this one, this is called ASCII code. This is 1000001. So this 7-bit we preserves to represent each letter in the keyboard, So and if you apply parity checking, so that means it would be then 8-bit, but whatever, let's say the 7-bit or whatever the coding techniques you use, it doesn't matter now. So the main thing is that the text you can represent in ASCII code or Unicode or whatever. You are basically converting to some sort of binary number. Similarly, B is this is the binary number, D can be represented with this binary number. So multimedia data, whatever forms that we see or we human understand, computer understand, is basically a sequence of ones and zeros. Thus this is all about. Now if you think about the audio data, you see if you record an audio voice using some mobile or somewhere, you perhaps see these sorts of things, right? What is this? This is basically a very maybe 1 second or something, or very tiny segments of our audio data, right? It looks like analog signals. Now if you just expand this portion, so if you just closely look, so perhaps let's say this is a very maybe only this part, maybe if you just expand, this looks like this one. Okay, now you see this axis, let's say as time goes on, the signal sometimes goes up and sometimes goes down. So this is what happening, right? So let's say we are just particularly at this time instant we are talking about. So at this time instant, the value of this audio signal, let's say 4, and 4 might be millivolt or whatever. Let's say this is 4, And then this 4 you can actually transform to a binary, let's say 100. Similarly, at the next time instant, maybe this signal is 3, so you just convert it. So ultimately, again, this segment of audio signal we can convert is a series of numbers. So that means it's a series of binary numbers. So this is all about that how we think of. Now, if we now see how the image data, let's say this is an image data. Now, when you convert, definitely everything we need to convert to numbers because computer understands only numbers. So let's say the very first pixel and the second pixel and the third pixel, each pixel, let's say a number, right? So ultimately, and this pixel, what number it is, it depends on the image, gray level. If gray level is high, very white, so maybe it is high number. If its gray level is too low, there is a lower number. So ultimately, this becomes an array of numbers. If you just convert it to this one, this is becoming a one number, second number, third number. This is basically a two-dimensional numbers. So the image is then what? Image is an array of two-dimensional numbers, or is a two-dimensional array of numbers, right? So again, that if you just take one number and that number can be converted to binary numbers, again it becomes ones and zeros. Now how about the video? Video is basically simple thought. We can consider that video is basically a sequence of images, right? That images actually play very fast, one after another, very successive, maybe at each second maybe 30 images we can see. So that become now video. So ultimately, video is basically a rapid succession of images. And we know that each image is basically an array of numbers. So is a series of array of numbers is basically video. And what is animation? The animation is also, you can think the animation, it can be considered as a dribbling ball or some sorting, same things repeating one after another, right? So that's called animation. So there, some particular portion of the image we can actually, repeat itself, with some predefined delay or in some way. So that can be considered as an animation. So this is again is coming from some sort of image. So you now understand, text data, you have audio data, you have an image data, you have an animation data, you have video data. It's all basically numbers. So this is multimedia data, and now we will deal with all of this multimedia data. Okay. Now when comes the assessment, see that we have assigned 25% for midterm exam and 25% final exam and 40% for assignment. And assignment might be diverse types this times compared to previous semesters. I'd be taking the homework, quiz, group project, and also you might have some survey, review, analysis, reporting, problem solving, programming, and some other tasks that I'll be explaining when I upload the assignments, and according to the instructions you will do. And total score obtained from all assignments will be proportionally converted. Let's say we just total quiz or homeworks or whatever all together. Let's say we have 10 tasks. If we have 10 assignments together, and we have let's say total marks, and then we'll convert that total score to 40% score. Okay, and we'll have attendance 10%, and the midterm exam and final exams, we don't know yet the how we will be taking, I'll be conducting, but you can have an idea that it would be multiple choice, true, false, matching, or completion stuffs. And it also might have subjective, but that will be might be short answers or extended response or problem solving. So course materials, I'll be providing the PDF slides. So that means this slide I'll be uploading, and it will be available on Blackboard in Sejong University. You all have your ID and passwords. You just log in with that. You go to the course menu, and then you will find it. For online lectures, the contents will be uploaded in the Blackboards. So that means the video contents, okay, the video contents. And time to time, some more references and maybe some lecture notes, maybe given from time to time. And for something, for implementation or some programming aspects, for exercise perspective, some examples that will use MATLAB. I'm not sure that we'll be using OpenCV or not, but perhaps at least one example we can do. And FFmpeg, this is also a good multimedia framework and tools that we'll be using, and maybe something on Python. Especially if we do image, we will use MATLAB and Python, and if we use audio, video, some decoding and encoding stuffs, we'll use FFmpeg. Okay. Now the outline of this course is very simple. You already maybe saw the syllabus that I have uploaded in the Blackboard, and also in academic information systems. So from the syllabus, I'll be explaining one by one, but the overall, the objective or outline of this course is something like this, that will be trying to understand multimedia data and image fundamentals. Because if you understand image, this basically talks on, and that basically forms the basis of video, audio, and not audio, and video and animation. So that's why grasping the fundamental concept on image is very important. So we'll be seeing the overall next week the concepts of multimedia data and image fundamentals. And then in the following weeks, we'll be seeing the color science and color models. Or another, good intentions of this multimedia is to understand the compression techniques, because the data, when we produce the raw data, audio, image, or video, it basically very large in volume. So we have to compress the data so that we can, utilize it very effectively. And then we'll be understanding something, multimedia frameworks and tools. So by the way, I'm just using MM, it means multimedia. And then we'll see the data visualization, computer animation, and AR, VR technologies, augmented reality and virtual reality stuffs, because that's really becoming a significant part of in today's multimedia world. And then we'll be seeing that, machine learning, how, we can apply in multimedia applications, because, the AI and machine learning becoming a new electricity. So wherever and whichever field you are studying, we have to apply these advanced computation techniques, that is machine learning or deep learning, and that we will be learning, okay, in this course. And then we'll be seeing some things on multimedia communication networks, because ultimately we are not confined any multimedia stops within ourselves, within the computer systems. Ultimately we are communicating over the with other parties, so over the computer networks. So some communication concepts you also need to understand, at least some basic idea. So if we talk about the syllabus is very one-to-one mapping of our outline that we provided. So we'll be seeing image data types and image file formats, and then various kinds of color models we'll be studying. For example, RGB color model, YUV color model. And in compression techniques, we'll be seeing both lossy compression and lossless compression, and this will include MPEG, audio video compression algorithms, AVC, that is advanced video coding, and even the latest ACVC, so that is very high performance enhanced video coding. And then in the multimedia frameworks and tools, we'll be coming across some concepts on how these things works, OBS and FFmpeg, OpenShot, OpenCV, these sorts of multimedia frameworks and tools we'll be talking on. So then comes the data visualizations. So in data visualization, you see that there are different and diverse ways, and every day some new forms of data visualization techniques coming. For example, it might be this one, there's a heat map. These sorts of heat maps basically used in genetic data presentations. We have network data presentation. It looks like a networks composed of so many nodes, and those we have new scatter plot. We have this scatter plot are useful in many for data understanding. That where it is located, how the data is converged in one place or is scattered or dispersed. So this sort of perspectives we can capture by the scatter plot. We also have radar plot. We'll see what are those. So even the visualizations might be interactive. For example, when you are doing the brushing, painting, so that are kind of interactive data visualizations. Okay, we'll also see something. It is not really related this computer animation. It is perhaps more appropriate to deal in computer graphics, but because it's multimedia, a little bit related, so we will coming across some principles of animations, especially techniques and modeling ways. And then we'll see that how AR and VR might be useful in different applications, even including healthcare applications. Then, as I told you that we'll be seeing some sort of virtual characters. So this actually, the basis of those things is actually machine learning, or more appropriately this one, GAN. The GAN is maybe, this is, the abbreviation is generative adversarial networks. So generative adversarial networks, by using that kinds of, by applying that kind of advanced computational methods, we are able to produce some deep fake image or deep fake image. So we'll be seeing that things, how it comes. And then definitely multimedia communications and retrieval. Retrieval means you have the multimedia storage and databases, and then from that multimedia databases, how we can retrieve the content itself. So that's our syllabus that we'll be trying to cover in our this course journey in the second semester of this year, right? Okay, so yes, you are able to contact me, and this the email communication is preferred, because this has some values, right? So this Gmail address, it is better you contact through Gmail address, islam.smriyaj. But you can also, because this is my official email address, you can do so, but Gmail is more preferable. And then you have, whenever you contact, please mention your name, ID, and course, because this is mandatory. Sometimes users say name and ID, but I don't know which course you are in, because if you don't say that your course, because I'm actually, conducting other courses as well, so it become confusing. And you can come to my office, definitely, but it's better to have a prior appointment. My office is AI Center, and the room number is 434. So, and always be professional, because we need to practice this professionalism, because it's not only with me, with any other person, any other corporate office or office, or outer world with other professors. Even after finishing your this undergraduate degree, you all need to communicate in a different scale and different level. So so this is your email structure that should be. The email has a 6-7 components. So mostly this is a to field and subject field. You always mention the subject very specifically. For example, this is a multimedia lectures. Perhaps you are talking about an assignment or grade or project, exam or meeting. So you need to specify that things. And then you just write this professor, my name is Riyazul Islam, okay? And then introduce yourself with your name and ID, and then you describe the issues, and then you say thanks. And it is also good again to put your names and details, because without this signature, the email doesn't look good. Okay, so this is how you will be contacting me. I may not respond to you if you don't follow these structures. And they who already perhaps took my lectures before, perhaps that I'm very sensitive on this issue. Now this is I am giving you, right? Now when I reply, I may not reply in a very in details, because many emails usually comes to me, and it is very hard to give you reply accordingly. But when you send the email, you become more professional, because you actually contacting for your needs. Okay, so assignment and homework via email is not acceptable, and assessment rubrics will be followed to evaluate this assignment and project that we explained, that how midterm assignment will be evaluated. And definitely whatever you and I think it doesn't matter, we'll follow the university department rules and regulation. And always the honesty will be appreciated, and we'll be explaining something more according to our needs. And then you have the other things, that maximum number of permitted absence is 7. So that means total we'll have 30, at least 30 lectures. That means not 30 weeks, 30 lectures. That means each week 2 lectures. So among that 30 or 32 lectures, you are permitted to be absent on 7 lectures. Okay, and if the number of absence exceeds 7, your grade will be FA automatically. It's not in my hand. These are the recommended textbooks, the fundamentals of multimedia, and this is the second edition that came in 2014. Maybe its latest edition also came, and that is maybe 221 or something, maybe third edition. But second edition is pretty much fine. But then you have another book. This is a secondary auxiliary book, Multimedia Computing. This is also a good book, but I'll be following this one. But then, because this time compared to, I also taught this multimedia course before also here in this university, but compared to the previous semester, in this semesters many new topics have been included. For example, AR and VR, principles of animations, then data visualizations. So the other part have been squeezed and these parts have been newly included. So that's why these all of the things are not included in these books. So for that, you'll be relying on some other sources that I'll be giving at that time. Okay. For example, the different other reading materials and online references. Okay, so this is our course information. So now we'll be moving to the next part. So this part is 10 minutes shorter, but the next parts perhaps would be sufficient enough to make our at least 76 to 80-minute lectures. Okay, so let's move to the next part.